so we have been talking about electric current, and from our discussions, we can see that current is determined by the push or the potential difference that allows current to flow, but current is also affected by resistance because resistance hinders the flow of current. So from this relationship, what do you think? How do you think is current related to potential difference? I'll just use V. To potential difference or voltage. Are they directly or inversely proportional? Okay, current is directly proportional to potential difference. That means the greater the potential difference, the greater the current. Well, it makes sense because, for example, we have one battery and that it is connected to another 1.5 volt of battery. So when a charge is, when this first battery does work to this charge will come up out here carrying 1.5 joules of energy. And then, will that energy be used up? Not yet, because it's here in the next battery. And this battery again will do work on this charge in pushing it from the negative terminal to the positive terminal. And when it comes out, this charge, how much energy does this charge carry now? This charge now carries 3 volts of energy. Oh, I'm sorry, 3 joules of energy. Okay, so it makes sense. The higher the PD, the greater the current. What about current and resistance? How is current related to resistance? They are inversely proportional. It makes sense, right? Because the greater the resistance, the harder it is for the current to flow. So, combining those relationships, that current is directly proportional to voltage and current is inversely proportional to resistance, we now have this formula that current is equal to voltage over resistance. This is a law, and we call this as Ohm's law. So Ohm's law states that current is directly proportional to voltage at constant resistance, and current is inversely proportional to resistance at constant voltage. Okay, and I would just like to add some other power equations. So remember, in terms of electrical energy, power is the product of potential difference and current. And from Ohm's law, we can see this current is equal to V over R. We can substitute this I to this I in power. So we will have power is equal to potential difference times potential difference over R. So we now have a new equation for power, which is potential difference squared over R. And also there's another formula for power from the previous one, from the original one, which is this. If we arrange this Ohm's law so that we'll have V is equal to IR. Always remember this potential difference, so there's a triangle here. We can substitute this here. And so what will we have? P is equal to IR times I. Simplifying this, we will have power is equal to I squared R. Okay, so from here we can now have the 3 formulas for power. The original one, power is potential difference times current. And the second one is power is equal to the square of potential difference over R. And the third one is power is equal to current squared times resistance.